Sir, shall we
So,
start, sir?
yes, madam. Yes, madam. Yes, madam.
Start பண்ணலாம்.
A very good morning to one and all present over here. Welcome to AECT sponsored Sttp on IoT with blockchain applications
Good
and
morning,
challenge.
madam. Good morning.
Series 1, Day 2. I feel extremely honored to introduce our resource person of the session, Dr. R.P. Ramkumar, Professor, Department of Computer Science and Engineering, Malareddy Engineering College, Secunderabad. He completed his graduation in CSE at Karunya Institute of Technology in 1999. He then completed his master's in Computer Science and Engineering at Mahendra Engineering College in 2007, followed by his doctorate at Anna University by 2015. He has a multi-faced experience of over 16 plus years in teaching sector and about 2 years in industry. And he completed an IBM academic certificate exam for Data Scientist Mastery Award for Educators 2017 and completed a course of study on DLI platform course instructor offered by the Deep Learning Institute NVIDIA in association with Bennett University. He completed a certificate on image classification, object detection, and neural network deployment with digits with NVIDIA DLI in association with Bennett University. He have published 3 books and have filed 2 patents so far. He also published his works in various national and international journals. He is a professional membership of LMCSI, LMISTE, MIEEE. It is a great privilege to have such a wonderful, dynamic personality with us today. We feel honored by your presence, sir. On behalf of VCET and Department of Computer Science and Engineering, we once again welcome you, sir. Now, let us welcome our resource person of the session, Dr. R.P. Ramkumar, sir, to move on this session forward.
Thank you, ma'am. Thank you for the introduction. First of all, madam, whether it is audible, ma'am? Hello.
Yes, sir. Audible, sir.
Yes, fine. Thank you. Thank you. Thank you for the response. Yes. Thank you for inviting me as a resource person. On behalf of ACT, VCET, and MRC, I thank for giving this opportunity. Straight away, we'll start the session. Yes. Yesterday, the participants are given an overview of IoT and blockchain, right? But with that introduction, now in this session, we are going to have a glance about IoT, IoT's Internet of Things, responding building blocks, the basic building blocks of IoT, what constitutes of IoT, then protocols and technologies, the concern security and challenges related to IoT. Whenever we are going for IoT based applications, what else the protocols are related in it? Prior to that, what comprises of blocks, building blocks or basic building blocks? Then if you are doing so, then what else the security and challenges has to be processed, right? First of all, I want to represent that in the title page itself, I have given compiled and presented by. Here, what else the images I am giving or what else being represented? The first image which is being shown here itself is being the corresponding reference I have given here from where it is cited or from where it is being downloaded, used, because much more thing what else available in the Google, it becomes either you can use by CC or else even with copyright issues. So to what else been available with CC and also as well as with to justify with the content, what else from where we have recruited or from where we have adopted, right? The same slide I have represented the corresponding references to for better understanding to avoid the violation of copyright issues. And for that only I have given the front page itself as compiled and presented by. 99% is already everything is available either in the form of PPT or else in the form of book or else in the form of web pages. That's why I have used this word compiled and presented by, right? Fine. Introduction to IoT. Here, apart from that, for better understanding, I would like to represent few examples then and there. For intentionally or not intentionally, I am not going to represent anything anywhere else or any other profession. for example sake and better understanding alone, we'll be using those sort of examples, right? Not in to refer or to make something else being prescribed, right? The term IoT, what is the term IoT refers means, it is used mainly to communicate the human with respect to the corresponding machines. That's what the term is. Very emerging technology. In short, we call it as IoT, and it is coined by Kevin Ashton from the United Kingdom in 1999. Right. What if I'm going on communicating or connecting the human with the machines? What else the way in which I can connect? There are two forms. Either it might be wired or it might be wireless. Okay. Either irrespective of that whether it is wired or wireless, what sort of data you are going to collect and how you are going to process it, from which environment or from where you are going to collect. Once you are collecting the data or collected the data, what you are going to do? You are going to share the data or you are going to communicate the data from the environment to further for further processing. That's it. In one line, if I want to represent means it is a communication between the machine and the human. Right. That's it. Again, if I want to refine the definition again, either the communication between the human and the machine can be of either wired or wireless, right? From either it may be wired or wireless, just I'm extracting the data, after that summarizing it and passing the data to some other remote places, not only the remote places, some other places for further processing, right? That's what that IoT refers to. Now this according to Goldsman Shah, he refined or he specified 5 key attributes to memorize or to summarize. We call it as sense framework. SENSE. That's what we have given here. Sense. See, as I represented, from where the corresponding context or this text, either it may be a text or an image or a code, is being represented in the just the last line of the slide I have specified here. If you are seeing it now, where I am keeping my mouse here, the last line I have represented the corresponding references where it is being cited. Right. So, as I already said, either it may be a CC or it may be a copyrighted material. So, cite is the corresponding references we are providing to them. Right. Yes. Coming back, according to Goldsman's chart, the 5 attributes with respect to the IoT has sense framework. Right. That what is that sense framework represent? First, S stands for sensing. From where we are going to collect the data. That is leveraging sensors to generate conceptual data. We are going to generate or we are going to extract, we are going to get the data. This is what that sensing refers. Coming to the second letter E, efficient, right? In whether what way in which we can able to getting the data is not at all a problem. We need to get the data in an efficient manner, right? Enhances efficiency in productivity terms by adding intelligence to the things. Just we want to get the data, that is sensing. We want to get the data in an efficient manner, that is efficient. The third one, network, creates a network of things. That means we need to share the data directly from where the data is being generated and the data has to be processed. Cannot be or need not be at the same location, right? In those scenarios, we need to share the data or we need to communicate the data. In those scenarios, we are in need of network. That's what the third letter N refers. Coming to the fourth letter S, specialized. Ultimate use is focused on domain-based specialized offerings. What else the way we are adopting for a particular domain cannot be necessary or cannot be made mandatory for other type of applications also or other type of domains also. That's what either first you are collecting the data in an efficient manner and the network manner you are doing it. Up to this is what the first 3 letter represents, right? This is what the first 3 letter represents. The fourth letter coming to that specialized or specialization, the way in which we are collecting, processing, and efficient manner, networking need not be the same for all sort of scenarios. That's what they were representing. It is completely depends on the area or the domain or the environment or the scenario where we are working on. Right. The last one, the last letter E, everywhere, can be deployed everywhere as per objectivity of use, irrespective of the location. Right now, if I want to quote one example here means machine learning. For example, machine learning is a domain where there is no any domain such that we cannot apply machine learning. Right from the agriculture to the even to the missiles launching also, we are now due to the advancement in the technology, we are applying machine learning. Right, the same case. There is no any environment as of now that IoT cannot be deployed, right? That's what that last letter E everywhere represents. I'm summarizing SENSE, sensing, just collecting the data, efficient, the collected data should be efficient, and the network for communicating the data from the generated place or the environment where it is being generated or collected to the process data we need to communicate. For that, we are using networking. Then based on the environment, the process differs or the procedure differs. That's what the fourth letter S represents specialized. And the fifth one, the same methodology where we can adopt for all scenarios, right? Just to avoid getting bored, I have used then and there some images so that you will be feel much more comfortable, right? Or very simple example, mostly as of now, just a minute, how many members have joined? Let me have a look at it. As of now, 30. Yes, mostly everyone is from CSE, means they will have a very good background. Apart from that, for others who else is not related to the CSE domain, I thought of representing a simple example what that IoT stands for with a real-time example. Nowadays, if you are seeing an advertisements of Whirlpool, see, as already I said, I am not promoting anyone else. I am not complaining anything else. Just I'm all the examples and the representations are being for better understanding purpose alone, right? As I'm example stating that Whirlpool example for a fridge, refrigerator, or else even other thing means I'm not promoting. I'm not finding any faults in it, right? Just I'm representing. Wherever in advertisements, if you are seeing one grandpa will be coming and just he will be speaking to Alexa, turn on AC directly, it ons, right? That means the machines are being connected, and through Alexa, through NLP, what else we are communicating, that too, that Alexa is being again interrelated or connected with our mobile phones. That is the operation called as synchronization, where the mobile phone is synced with the Alexa, and whenever you are using directly the concerned language, need not be the language specific. If you are working in Tamil Nadu, you need to speak in Tamil. Even we can make it, or either in English, or based on the environment where we are working on, the corresponding local language can also be used to communicate to Alexa. Through Alexa, whenever you are saying directly, it connects to either to the smart screen or else even to the refrigerators. Even this is the best example for IoT communicating between a human and a machine. The one more example I want to represent is that there are some intelligent refrigerators where equipped with a specialized trays for specialized environment, specialized objects. Say call it as there are specialized trays in which you can able to keep orange or banana or even the ripe fruits, stating that the sensors will sense the objects. That means what else objects are kept there. For example, for our consideration, we'll keep I'm keeping a banana or else apple or even a tomato, right? The sensors, what else sensors are equipped in those specialized trays, it will be going on analyzing and testing the content or the current status of those fruits. If it is getting more ripened, then it gets and it sends an SMS to the concerned synced mobile stating that these are the current status of the ripened fruits. If it after beyond more ripen, if it is going for delayed or decayed stages or states means, then accordingly it has to be notified. It will be notified or it has to be notified to the concerned user stating that these are the fruits getting decayed and it has to be replaced or it has to be used at the earliest, right? The same machine is being, and vice versa. The humans can communicate to machine and simultaneously the machines will communicate to the humans, right? That is the very best example for IoT as of now for better understanding, right? Coming to the IoT history, here in 1830s itself, the telegraph have given, that is where the machine started, the human started interacting with the machines, right? Second half of the 19th century, the machine to machine, M to M application started. Then smart devices started in 1920s, 1980s. The smart devices ever that vending machines, that is automated. Whenever you are dropping money, you will get some equivalent to that of some items. Best example is in advertisements, we will be seeing Pepsi vendor machines. Just if you are dropping 10 rupee coin, you will get a small Pepsi tin or can, right? 1990s, accordingly, the first toast via internet. Then WWW, World Wide Web, was proposed in 1999. That is, these are the history where it is being represented from this If anything went wrong, either I cannot or you cannot claim it. That's why for every images or every content, I have given corresponding references there. The number of IoT devices exceed world's population in 2018, whereas in 2020, now estimates for connected IoT device reaches 30.3 billions. You just think about it. Just earlier 2015, it was nearly two-third increase about that of the total population. Now it got, and again in 2025 they are predicting that it goes nearly more than 10 to 12 times above the population. That is the number of connected devices throughout the world. Yes, a small, the same advancement of that diagram. See here, prior to that internet, human to human, pre-internet. That is, whenever there is no any internet, prior to that, see, fixed and mobile telephony, SMS was there, human to human connection. And whenever there some sort of smart networks coming to the role, stating that here human to human connected, they were sharing the data either through email or information through www. This is called as Internet of Content, right? Again, we are adding some more smartness such that smart IoT platforms and services such that e-productivity and e-commerce launches, their web 2.4, 2.0, their internet of services come into the picture. Again, we are adding few more smartness to it, that smartphones and also as well as applications such that the Skype, Facebook, YouTube, all sort of gigantic data generators. That's what we call it as social media, right? This is called as Internet of People. Again, adding few more smartness with due to the devices and objects data where comes into the picture Internet of Things. See here, prior to the internet, just human to human we are discussing, whereas now due to the Internet of Content, Internet of Services, Internet of People, all put together, we are into the era of Internet of Things where machine to machine can communicate each other. That is identification, tracking, monitoring, metering, automation. See, everything is being automated. That's what I use the word such as stating that there is no any environment such that IoT cannot be deployed. Right. That's where the smart data and ambient contacts. Right. This is what the evolution of IoT. Just a minute. So, yes, IoT roadmap. The same diagram with some more additional features. The same diagram. The earlier is ranging from Internet of Content, Internet of Services, Internet of People. Whereas coming to here in the year wise, in 2010, see here in the 2000 ranging from 2010 to 2025 and beyond. If you are seeing, see here that home and personal alone we were using concentrating much more usages. Whereas coming to 2015, from home and personal usage, it moved to enterprise, right? Then again in 2020, from enterprise, it moved to utility. Whereas 2025 and beyond, they predicted that mostly it will be applicable for utility, transport, plug and play smart objects. See, whenever we are going for diverse applications IoT, we can able to see from where, see here, smart sensors in healthcare, whereas RFID in retail industry ecosystems, critical infrastructure monitoring, whereas smart traffic automatically event driven. Here I want to identify or represent one very best example here. Earlier and all, we used to go to departmental stores for collecting items, and that too, if you are representing some sort of items, for either it may be 5 or 10 items, we need to go with some content and accordingly that write-ups. And if you are going on informing them, they will prepare, pack up, and they will give to you. For example, the grocery items, right? Whereas nowadays, you just see to that, even there are some much more malls in the high-tech cities where no need of just representing. Just if you are texting them directly, it will be ordered. It will place an order or online. For example, even Amazon, you just think about it. What else item you want, you are searching for, you are identifying, placing the order, and it will be delivered within in a day to 5 days. Whereas coming back, you are going to live example of purchasing some items from the groceries. You are going, taking the trolleys, what else item you are making it, coming back at the payment, the location itself, just they will be scanning and immediately, even much more specialized higher end shops if you are going means there won't be any customer biller there directly. What else the items you are purchasing, automatically it scans, generates the bill, and even no need of swiping the cards, just showing the card and automatically it detects and you can come back. Those are some there are some shops like this. Likewise, you just think about it, those all relates to IoT only, completely sensors. As what we said, sense na, SENSE in the earlier example, the first beginning. See, SENSE, sensing, efficient, network, specialized, and everywhere. It depends only on where the environment we are adopting, right? A complex ecosystem of IoT, right? Complex ecosystem, the same sense it goes. See here again, the SENSE we said, but as per this statement, see, or this what they have done is sensing. For example, the temperature, gyroscope, or pressure. These are all some examples. What's represented in the white color? You come back. Whereas here, sensing, embedded processing, and connectivity. The entire sense is being compressed into 3 titles, right? Whereas how the users and the corresponding environments are clubbed together. See, either it may be a smart grid, or smart lighting, or smartphones, smart energy meters, smart cities, smart farming, or smart energy, or smart homes. Whatever the content, whatever the application, what we can do is either the users or the groups or communities. Communities mean the enterprises. All our group are connected. These 3 concepts. That is sense only. Again, the sense is being segregated into 3: sensing, embedded processing, and connectivity. Right. What else the way in which you are connecting either GPS, Wi-Fi, or RFID? What else the way in which you are going to process it? Hybrid, MOU, or MDB, or networked process. Some processor you are having it to process it. Right. Whereas either it may be with application or software or technology. Somehow, if I want to go in depth to the ecosystem, see here the same content. What else we have said? The complex ecosystem, sensing. The first one, sensing is here. Na? The sensing here. The IoT ecosystem sensors its surroundings like temperature, gyroscope. That means what else the velocity is being changed in the velocity is said to be as gyroscope. That motion changes, right? Pressures, all these things. Either what else the way you are connected is different, immaterial here, right? Smart devices and environments. What else the way in which you are receiving the data? See here, the data transfer or receive. But as technology, software applications, what technology you are using? Either we can go with Arduino or with Python or even what else the language or the corresponding environment you are interested. Even you can go with Java. That's what the technology or the software or applications, right? Users or group of community whom they are going to target or whom they are going to use. The product or services generated by IoT ecosystems, right? Consumed by the either it may be one user or users or a group of communities, right? Somehow going in depth or having zooming the concept where this particular the sensing or embedding processing or connectivity, this ecosystem, we are going to zoom this now. That means how it works, right? All whatever the IoT framework or wherever the environment we are concentrating on, it is going to stick on to only strategic decision making, right? How the on gathering the data, just passing the data, communicating, and I'm going to analyze it. With that, what I'm going to do? That is strategic decision making, right? There are 5 different layers. There are 5 different layers to make the decision framework of IoT. Those are device hardwares. Second one is device software. The third one is communication. The fourth one is cloud platform. The last one is cloud applications. I repeat, IoT decision frameworks, whatever the application you are getting it. At last, if the if time permits, we'll go with one case study. I'll get back to you. Based on the availability, we'll go with at least one case study, right? Device hardware. Device hardware, first of all. The second one is from the hardware, we need to extract the data. For that, we are going for using software. After collecting the data through the software, we need to communicate it. After communicating, we need to process or analyze, right? After processing or based on that analyzing, we need to go for corresponding applications where it uses. Either it may be used for analytics or predictions or classification. Whatever you want, we can do it. These are the 5 decision frameworks, right? Which is abruptly represented are known as strategic decision making. With this 5 decision framework, what we are going to do? See here, all the decision frameworks are checked against 6 decision areas, irrespective of the products. If you are those who are doing research, those who want to do research, or they want to explore more about IoT, this table or this chart is very useful, right? The IoT decision frameworks. What else the frameworks? What we saw in the earlier slide. That is hardware, which is responsible for generating a data or collecting the data. From there, we are for processing for software. Then communication. Then it has to be sent for cloud platform for further processing to the concerned cloud applications. All these 5 frameworks are checked or validated with the decision areas. We call it as the 6 key decision areas, right? The first and foremost thing is user experience. The second one is data. User experience is represented as UX. This UX means it has to be applicable or satisfy all the 5 decision areas, all the 5 decision frameworks. Then data, then business, technology, security, standards, and regulations. For one example, you see to that wireless body area networks is there, WBAN, wireless body area networks, WBAN, BAN. Just in movies and all, they'll be very easiest example I want to represent means from examples, we'll take it from movies. Recently, one hero just he will insert, or in James Bond movies and all, if you're seeing, he'll be injecting a small sensor to the body, and wherever he is going, the corresponding he'll be tracked, and by the same way, either he can be tracked and he can share the data from where he is, and either through voice or messages or signals, whatever the medium he wants to use, he can use it, right? The same case, these 5 frameworks, hardware, software, communication platform, and cloud applications, has to be satisfied with 6 decision areas, right? The responding, see here, user experience, that is this is the area where the concentrate about who are the users, what are their requirements, and how to provide the data. All deals with user experience. Coming to the data decision area, that is overall data strategy, such as from where I'm getting, from where it has to, whether whatever the data I'm getting, whether it fulfills the user requirement or not, right? Whereas business decision area, the third one, the business decision area, the third one, it is used for making the decisions, whether based on the past history, what else the way in which we can move, or what else the way in which we can proceed further, right? Either it may be a financial decisions, or it may be a environmental decisions. What else want we can do it, right? Then the fourth one is technology. See here, technology decision areas. We work with the technology for each layer to facilitate the final solution. That is completely up to the software environment team where they are interested to work with. The next fifth one is security, standards and regulations. Security plays a major role with respect to IoT, because all the data is exposed, because from environment only we are environment and end user we are collecting the data. Since more number of users, more number of vulnerabilities, that's it. Directly those are directly proportional to each other. Security decision area. After going through the implementation of technology, it is important to design and provide security at each stage of IoT stack. It is very difficult. Next IoT protocols we are going to see now. By the time you can able to see that how much layer or how much it is very difficult for us to secure the data, because that much of vulnerabilities are there, right? Standards and regulations decision area, the last standards and regulations. See here, at the last stage of IoT decision area, we identify the or define the standards and regulations of products or the services. Here I want to represent one very basic example, that is of very basic example of webcam. I'll tell you, right? Whatever the laptop or else the desktop or very simple machine system you are using it. Now even if you are purchasing a very local or basic level to the higher level of webcams, just you are getting it from the market, either online shop or else offline shops, you are getting it and connecting to your system, immediately it starts working, right? Irrespective of the company, irrespective of its model. Then you think about it, how far they were concentrating on standards, either what else the operating system you are working with. Only based on the operating system, you need to install the corresponding device drivers. That is immaterial, you leave it. Whereas you just think about it, for the basic webcam itself, they are going on sticking onto the standards and regulations. Means think about it, how far they need to work on the IoT devices for gathering the data from different scenarios that has to be managed for all environments, right? That's what it is very, very, very difficult to satisfy all the decision frameworks, all the five frameworks, all the five frameworks has to be satisfied with 6 key decision areas, right? Coming to that, how IoT works. See, the sense we said, right? The same again, once again, this is the somehow the detailed procedure, or somehow we are keeping a lens stating that I'm identifying much more in depth, right? The first and foremost thing is hardware, right? How will you capture the data? That is, it deals with devices, sensors, and actuators. For example, temperature sensor, or pressure sensor, light sensor, or altitude sensor, etc. The first and foremost thing is hardware directly. Then hardware is connected through connected. That is said to be as connectivity. How will you connect to the internet? This is what, how the data hardware is there, that how the hardware will be connected to the internet. Choose a connectivity protocol based on the environment. If it is very short distance, if it is somehow moderate distance, if it is a much more long distance, what else the connectivity I need to prefer, that deals with the connectivity. After connected, after making the connection or after establishing the connection, what I need to do? First hardware, then I'm establishing a connection. After establishing a connection, I need to share the data. That is, how will you get your sensor data from the device to the cloud? What else the way in which I can able to share the data? That is sending the data, connecting devices to cloud with over 50 plus firmware libraries for analyzing it, for processing it, for getting insight into the data. Very simple to represent. I need to get insight on data, what for what it is. With that insight, what I can go proceed further again, right? After that, need to store the data for further use or future representations. How will you store and manage your data, devices data? That is optimized time series backends. Store, manage, and recall devices based on the data size and capacity and its importance, right? After that, we are going for visualization. That is, now I am going for exploring the data, right? How will you transform raw data into insights? That is, make sense of your data with visualization and alerts. With this huge data or enormous data, what we are going to get, or what way in which we are going to, what else results we are going to get from the raw data. After that, design and users management. How will you distribute your data on sites? Customize user access, application logos, colors, icons, permissions, and more. Right? Just in a one line, I want to represent means in a one sentence, I want to represent from the hardware. You are making a connectivity. After connectivity, you are sharing the data. After sharing the data, it has to be stored. After storage, we are going for getting insight into the data through visualization. After visualizing the data, we are going to act on it. That's what the IoT working principle, right? Yeah, three-layered architecture of IoT. Yeah, three-layered architecture of IoT. See here, application layer, network layer, perception layer. It is need not be that only the IoT should have 3 layers. Three is there, 3 layers are there, 4, 5, 6, 7, up to 7 layers are there. That's what we said. In the sense you could be able to remember, right? SENSE. Based on the scenario, it will work. Based on the scenarios, based on the scenario where we are getting it, based on the scenario where we are applying that IoT, it differs, right? Based on that, the number of layers also changes, right? That is smart home, smart city, or the smart government, all resides in the application. Whereas in the network layer represents the routers, access points, it diverts the data, right? The perception collects the data from sensors. This is the structure of three-layered architecture, right? See, again, somehow, again, I'm going on keeping lens to it and exploring more how it works, how it defines, right? That is here the perception layer, network layer, and application layer, right? Whereas here, activators, devices, gateways, and cloud. The same way, again, the stage by stage is being represented. How? Architect, how from the sensors or the activators, data is being collected and it is connected, connected to the sensor connected to the device. From the device, it is connected to the gateways through where it has to be bypassed or where it has to be transmitted or communicated. From there, the data is being given to the cloud for further analysis or visualization purpose. Right. Right. Stages of IoT solution, the same. What else we saw in the earlier page? Just we are communicating it. Again, here, See here, sensors, actuators. What it can do is it able to emit, accept, and process the data. Based on the applications, either it may be a GPS, global positioning system, or else electrochemical or gyroscope or RFIDs. Whereas this is with respect to sensors and actuators. What is responsible for emitting or accepting the or processing the data. Whereas coming to the gateways and the data question, it is used for completely transfer of data. Based on the, if it is very short distance, we can use the LAN. Somehow, if you want to process more data or more distance, then you need to go with a MAN or WAN accordingly, right? Whereas edge, it is an architecture which is used mainly for, whereas here, gateways, device, gateways, and clouds. That's what. The edge in IoT architecture is the hardware and software gateways, the other type of gateway, which is used for getting insight about the data. That is for pre-processing, basically removing the unwanted data. And you might be immediately asking, sir, how I can know that it is unwanted data? Based on the application, again it differs. Based on the application, again it differs, right? One, as we discussed at last, based on the availability, we will go for one case study. Whereas the data center and cloud, after pre-processing, completely extracting the data, then it is responsible for transferring the data or getting the data, storing and retrieving it for further purposes. Madam, it is audible, right? We can proceed further.
Yes, sir.
Yes, fine. If could not follow up or any network issues there means, please inform us.
Sure, sir.
Fine. Thank you. Thank you. Yes. The stages of IoT solutions architecture the same. What else we saw it here with one example we have given in this slide. This actuators, devices, gateways, and clouds is there now. The same concept, just we got presented with one example. See what else the sensors or actuators are there, and internet gateways. What else the internet gateways will be available, and IT edge analytics and pre-processing. Whereas data centers and cloud, you can see with the diagrammatic representations here. What will do now? Whereas if you are seeing, see stage one is collecting the data using the sensors and actuators. Either it may be wired or wireless, right? Whereas coming to the stage 2, where the gateways are there for data aggregation, analog and digital measurement and control will be there. Coming to the stage 3, here you can able to divide, see here where the edge stays. Here prior to this, stage 1 and stage 2 is there. After the edge, again stage 3, stage 4. Up to stage 1 and stage 2, just collecting the data, either in the form of wired, wireless, or sensors will be applicable. Whereas coming to the stage 3 and stage 4, directly deals with the analytics, pre-processing. That means I am working with the data, or we are working with the data for getting more insight on it. That's it, right? If you are seeing here, see the security where from stage 1 to stage 4, we need to ensure or enforce the security ecosystem and services. See here, end-to-end protective, in-depth security will be there. Whereas ecosystem means it should be open, extensive, and partner-driven. That means if irrespective of company or the corporation, all the standards should match. Then it should be a translative, integrative, operative, and managed. That's what the surveys represent. From stage 1 to stage 4, we need to ensure the security ecosystem and services. Whereas coming here, see the software stacks, the data flow. It flows from stage 1 to stage 4. Whereas control flow, from if you are seeing this control flow here, it will be in the reverse direction. That is, whenever the data is being generated, either wired or wireless, and for processing, it is stored in the cloud for further references. Based on the further references, again the communication goes back. With that, we will be refining one type of, for better understanding, even we call it as even feedback. Such that based on the analyzation, what we have came to the conclusion, we can refine or tune the performance of the data collections or the corresponding sensors, right? The potential smart services with IoT, where the IoT applications can be done. As of now, as we stated earlier, or else from the literature survey, or else what we have done is, there is no any environment such that IoT cannot be deployed. That's what. All the IoT is being connected to the cities, cars, healthcare, retail, traffic systems, and the smart traffic systems means very recently we have even IIT Madras in India. You can able to recollect the advancements what we have implemented already there, right? In railway systems, the smart CCTV cameras they have introduced, and by seeing the criminals or either by already from the database, if they are seen identified in any of the railway stations immediately, either in the platforms or else coming out or coming getting in, immediately it identifies and the alarm is being given such that the cops will be identifying the corresponding criminals and passengers will be safeguarded, right? Where you can think about that. You just think about it, how far we are much more advanced in the technologies, right? The smart factories, IoT potential applications. See, then time plan and smartness. Time plan. You just think, see here, that's what we said. Here, the billions of devices, number of devices in the billions. 2010, it was somewhere around 6.8, whereas see a timeline here in 2015, somewhere around 7.2, whereas in 2020, if that is the case, if the same growth proceeds, means it should be in this manner, world population, whereas here into 2020, whereas see here in somewhere else between 2012 or 2011 it went to 12.5, 2015 and around it went to 25, whereas 2020 it went up to 50, sorry, 50 billion devices connected. You just think about it, it is an exponential growth, right? This is what IoT's time plan. Whereas smartness, if I'm representing that anytime, any place, anything, that means anytime on the move or either indoor or outdoor or nighttime or daytime, anytime, right? Whereas any places, either at PC or indoor or outdoor on the move, any place also we can make it. Whereas anything can be connected, that is between personal computers, human to human, right? Human to thing and thing to thing. That means all the time, all the places, all the things can be connected or can be communicated through IoT and vice versa. Since because it is being communicating, we are representing it as IoT. As since because IoT it communicates, and vice versa we can represent, right? IoT building blocks. The same diagram somehow redrawn. The left image shows the same example, whereas coming to the right thing, see right diagram, IoT building blocks. The coming now slowly. I'm getting into the in-depth, right? IoT building blocks means things, gateways, network infrastructure, and cloud infrastructure. Now it's right time to go back to the sense again, right? The sense keyword. The thing from where we are collecting the data through the gateways we are sharing, started communicating to the secured or the constrained or the specialized environments through the network infrastructure. After the network infrastructure, we will be storing into the cloud for further usages and also as well as for getting more insight onto it, right? Or else for exploring the data or analyzing the data. Again, just thing, then gateways, then in network infrastructure and cloud infrastructure, right? The same building blocks. The description, the what else away the diagram's description is here. See. Things, gateways, network infrastructure, and cloud infrastructure. Whereas things means, see here, what else IoT devices relates with? Sensors or actuators. Allows to communicate and collect information from the object without the human intervention, irrespective of the location. For example, agriculture we will consider. Now, for this example, we'll go with the agricultural data or smart agriculture. And going on, we are having or considering around temperature temperature sensor or water sensor, or else even what else? For example, first of all, we'll consider as our humidity, or else rain, wind. What else a sensor you want, we can deploy. Whereas for example, for our consideration, now we'll have only the water consideration, whether what sort of humidity in the soil we are supposed to check. If it goes up certain threshold level, then accordingly the motor switch has to be on. So for that, completely for 24/7, we need to collect the data from the soil from there, right? Those are sensors. Whereas gateways, acting as an intermediate block and enables a strong connectivity between the things and the cloud infrastructure. Whereas it also provides a security and manageability abilities during the data flow. That is, from there it has to pass the data, it has to share the data, right? Coming back to the third point, that is network infrastructure, NI, where it comprises of routers, aggregators, gateways, and repeaters. That means routers, already in computer network subject we might have studied, right? Routers directly it routes the data, aggregators just it doubles, enhances the data, gateways it identifies from which network to other network the data has to be shared. Then repeaters, again for a long transmission of data we can have it. It allows control over data from things to cloud infrastructure, and while ensuring that while traversing the data from where it is being generated to the concerned networks, the security plays a major role. Security should be ensured. Right? The fourth point is cloud infrastructure, that is virtualized servers (VS) or data storage units. It allows the analytical or logical and advanced computing abilities. The same four concepts see here: cloud IoT building blocks, that is things, gateways, network infrastructure, and cloud infrastructure. The description goes in this manner. The things with networks and whereas again for easier understanding, few other companies they have made see here this four concepts we have said now: things, gateways, network infrastructure, and cloud infrastructure are integrated into three components, such as things with network sensors and actuators, in short we call it as TNSA, and information process data stores, RI, PDS, or PDS, analytical and computing engines, in short call it as ACE. Things and networked sensors, that is features of IoT component, that is basic buildings that are integrated into three components. These three components here, things with networked sensors and actuators, collects the information from the objects or things that were concentrated as per the specific application areas. Right. Raw information from data stores, RI, PDS. Right. Stores the collected information in various forms, either to be in the data or text or videos, images, and models. As already we stated, based on the scenario, the data collection of data or data collection differs. Right. Analytical and computing engines, in short we call it as, the acronym is ACE. It helps in human machine interactions and allows fast human requirements, as already we stated now. For example, in Alexa, if you are saying okay Google, you can reduce the volume by 35%, directly it interacts. That means earlier while switching on it was up to 70% or 80% of volume. Then if I want to reduce the volume, then it can be done in two methods. Either I can slide slightly at the right hand side for twice such that it reduces the volume, right? If not, I can directly represent over NLP itself, that is natural language processing, in my own language what else been interrupted or instructed earlier, or by the time of synchronization I can represent that Alexa, you can reduce the volume by 35%. Accordingly it reduces, right? That's what analytical and computing engine. It helps to human machine interactions and allows the feedback as per human requirements. This also allows analysis as per computing model chosen based on the requirement. That is, as already stated, that there is no any constraint or restriction such that it has to be in this manner. Based on the scenarios, based on the environment, it differs. Right? The same is given here. So that's what the diagram represents. TNSA. That means things with networked sensors and actuators. See, all put together in one unit. Whereas raw information and processed data storage (RI, PDS) is used for storing of data. Again, ACE, analytical and computing engines, all together form a cyclic order. See here, first the things generates the data. After generating the data, it has to be segregated, or it has to be segregated and communicated to specialized networks. That is, internet and external report status is being communicated, where raw information and processed data storages. Here we are processing the data. After processing, we are storing. Even for some applications, without processing, we need to store data. After storing, we will be processing. Right. After processing, we are going to do some analytics. That's what this analytics shows. That means the what action we are going to make based on the derivations of the data. Right. After that, what we are going to do? Analytical and computing engines. See here, modeling and analysis of data. We are going to do this. That's what. What else? Based on the earlier data, what we are going to predict, or what way in which we are going to react further. Right. That's what. Analytical and computing engines. Again, after this, just we are going back, giving to the same data into the things where the data is being collected, such that the data collection might be refined. Right. Feedback in the form of commands. Feedback in the form of commands. how the IoT components are interact with each other, right? Architecture layers. How, as of now, we have seen, as of now, we have seen how, what is the building blocks of, how, what is IoT, building blocks of IoT, and how the building blocks can be combined together as components, right? Now, the architecture layers, as we stated that very basic IoT comprises of three layered architecture, right? In the earlier class, in the earlier slides, where, yes, three. IoT structure of three layered architecture we have seen, right? Application layer, network layer, and perception layer. But this is not the stagnant one where this architecture alone can be applied. Based on the scenario, it differs, right? Likewise, now we are going to see just again, since I'm going on with the theory now, again it will be much more bored. So I thought of showing you some images where the IoT is applied, or applications of IoT in energy domains, exclusively in energy domains. See, for let me try to that. See here, architecture layers. Before architecture layers, I want to represent some examples. See, the approach of attaining a solution is based on how the information technology components are integrated with communication devices, so that the best hardware and best hardwares are integrated to each other, such that the data collection is made very easier, right? Then in brief, the software defined hardware systems helps in processing raw information into the processed data, such that storing, retrieving, and analyzing becomes very easier, right? Then what else? The way in which the architecture we want, we can customize it according to the requirements. For that, we want to know, actually speaking, the layered architecture has to come here. For better understanding, I thought of going with some examples, then to the corresponding architectures, right? This is an example of IoT in energy domains. Either it might be in the home appliances, right? Best example with respect to home appliances means, based on the amount of the count of clothes, what else we are uploading into your washing machine, it automatically selects the water level, right? That itself a part of IoT, right? Remote control and cloud services, the corresponding lights. Whenever much more, whenever you are entering into the room directly, it switches on. Whenever the lights will be on, based on the light, the required level of light is not there, or the luminance is not there, automatically lights on, and also along with the fan. Whenever the person is coming out of the room directly, the fans and lights will be switched off. Likewise, the high voltage AC also. Now in advertisement, you might be seeing, whenever the same AC acts as for 1.5 and 2-ton capacities, right? If more number of persons are available in the living room, directly it switches to 2-ton AC, such that the flow will be higher. If the number of persons will be less, then accordingly it reduces. Again, if there is only 1 or 2 persons in the living room, then it switches to 1-ton capacity alone, such that the power consumption is made, or power consumption is ensured, right? Security and safety, smart meters, store energy storages, right? This is with respect to energy domains. With respect to biometric systems, everyone knows it, right? Everyone knows with respect to the biometric system, your fingerprint or face recognition is being done. The first enrollment, then feature extraction stored in the data. Accordingly, whenever this is for enrollment, whenever we are going for evaluating it, then it checks and ensures the security of the concerned person, right? Then security systems for door locking, the same concept. What else we have done for our biometric system? Here the face recognition is done. Checks if the image of the person is present in the database, then gets the response. Once it is done, the point number 3, if the image is present in the database, then door is unblocked. If not, what it will do? Else notify the owner, whether notify the concerned admin, stating that whether I need to accept this person or not. If he is authorizing, then the door will open. If not, the door won't open. That means applications of IoT in security systems. Applications of IoT in smart home. You just think about it. In home, what else the area available, what else the options available, all are incurred in this diagram. See here, smart door lock, smart security system, smart air conditioner, lighting control system. Based on the environment, the light will be automatically turned on and off. Energy management, then coming back appliance control, then smart temperature, then smart bathroom appliances, then garage door opener. You just think about it. In home, everything can be automated. Whether irrespective of that, whether you are available in the home or not, if you want to take care of elderly persons, just with an IoT, you can monitor. You can monitor. I repeat, you can monitor, control, and reply to those devices along with the elderly persons too. Coming to the IoT applications, smart agriculture. Applications in smart agriculture. See it, drones for field monitoring, water management. What we are saying now, water management. We need to ensure that whether availability of water is throughout the farm or not. Either in the first initial level for first to 15 minutes. For you can please consider that there is a 10 acres of land, and if I am watering it for first few minutes alone, so that out of 10 acres, only 25% is being monitored or watered. The rest of the content is there or not, or else I need to walk to the end and I need to check. For that, what I can do is just I can fix up the sensors for every 1 acre, such that 10 sensors will be fixed up for 10 acres, and that when it reaches we can ensure that the water is being the crops are being watered till the end or not, right? Soil monitoring sensors, the machines for routing operations. This is the way in which we can utilize the IoT usage in smart agriculture also. Then IoT in smart healthcare. This is what is going to rule the world in pandemic situation. You might be knowing well, right? The smart healthcare. Earlier, we are not blaming doctors, but we earlier and all the telemedicine is not up to the level. Is there? If you are making a phone call to the doctor, then they won't be saying, sir, without seeing you, without consulting you, what they will do. Yes, the point is valid only. We agree. We are not blaming them because they will have their own constraints, right? I'm not blaming. Please, it is not like that. As already stated, the examples is for better understanding alone, not pinpointing anyone else, right? Here now, due to this pandemic situation, everything became online. So even you can book an appointment with the doctor in WhatsApp. Then through video call, you can inform them. Then just they will be giving you the prescriptions directly. The smart tablets are there. Since they are typing directly, they are writing as such set of prescriptions directly. Those contents are being texted you as messages in the WhatsApp. Then accordingly through online you can pay the payments, and accordingly that even the tablets also is being delivered by the corresponding persons. You just think about the options, right? Sensors, the data are collected through connectivity, then analytics, descriptive diagnosis, event-based actions, predictive, then application platform, then product infrastructure through mobile. Again, it is been given back to the sensor. Very best example I want to represent means one of our student. It was a live example, right? He somehow just I don't want to represent his name for a better understanding. I'm saying he was affected with severe blood pressure and also as well as sugar complaint, right? So he directly he consulted nearly 2 to 3 doctors and they couldn't make it. And when online doctor they approached, and they have fixed one just a smart wearable. That means two wearables in both the hands, one left hand and another one in right hand. For but somehow it's costlier only. But for threatening to the life, then no other we need to compensate for the pricing, right? That's what happened. And 24/7 they were monitored. He was monitored by them for nearly 7 days. That is just for 7 days. What else the morning breakfast, what else the lunch he's having, and what else the dinner he's having, and what else the items, and everything is being monitored. And after 7 days, collecting the entire data, the same thing, the same process was done. That is sensors, connectivity, analysis, application platform, and here all the data. What else the data they are collecting? Everything will be posted into the server that is in the cloud, and also as well as he can monitor in his mobile itself. In his mobile itself, after 7 days, they were giving some suggestions along with the tablets. Within 10 days, another 10 days, that is, first 7 days they were monitoring him. After 10 days, he completely made with zero. That is, this he made control with blood pressure and also as well as with the sugar level. You just think about it. But somehow the treatment is costlier only. But coming to the threatening of life, no other second way we need to do it, right? So in those scenarios, IoT plays a major role. IoT plays a major role in doing it. IoT plays a major role in doing it. Right. IoT applications in smart transportation. IoT applications in smart transportation. You just see here, either irrespective of that, either it may be flight or it may be either through airways or seaways or landways. In landways, either through the rail or else even through the roadways, all are being connected and transmitted through even in the tunnels or in the normal ways through the satellite communications. You think about it, how far the IoT is being helping us by all means, right? Getting into the next topic, that is IoT. As of now, just we have seen the building blocks of IoT, right? Now moving to IoT protocols, corresponding levels and deployment templates. Here, I want to represent, just a minute, I want to get a data from other one of the book. Sorry. Yes, this is completely specialized or content is being taken from Internet of Things and Hands-on Approach book by A. Bag and Vijay, right? From chapter 1, much more slides are there, but I have from the internet, if you are downloading, no, we need to enable to get this book, right? For this particular topic, for particular this IoT protocols, levels and deployment templates, right? Actually, the next topic what we are going to deal is IoT architecture layers, ranges from 3 layer, 5, 6, 7 and fog layers. Prior to that, we need to have some introduction about protocols, levels and deployment templates. After that, we will come back again, right? I have shared the second PDF, whether it is visible, sir? Anyone can please respond whether the screen is visible from my end.
Yes, sir.
Yes, fine. Thank you. Just because of I am changing the slides or entire files, right? That's what I want to ensure.
Okay, sir.
Yes, fine.
The
Thank
first
you.
page of the book is visible now, sir.
Yes, that's what I'm showing. That's what I'm showing. Yes, yes.
Okay, sir. Okay, sir.
Yes, the same content I'm getting it from there. But few slides in this here actually it comprises of 48 slides. Here I thought of skipping few initial slides because already we have discussed due to the time
Okay.
constraint. See, actually definition. What else the content is being presented in the slide is definition of IoT, characteristics of IoT, physical design, logical design, IoT protocols. From where we are going to start here. Actually, this already first four we not at all required, as already we discussed. IoT levels and deployment templates. IoT, what it is, formal definition of IoT, characteristics of IoT. See here, it is a dynamic global network and self-adapting, self-configuring, interoperable. This is the major, fantastic, excellent speciality of IoT to be concentrated. And if much more members who else is interested in doing research, IoT, they can concentrate on the third point, that is interoperable communication protocols. How it does communicate through various protocols, how it is, or is there any possibility of enforcing much more security sorry, more security through those protocols. Then unique identity, that is such as unique IP address and integrated into information network. Here physical design of IoT, things in IoT and IoT protocols. This is what we are going to deal with. Things in IoT, yes. Generic block diagram of IoT device. What an IoT comprises of, right? It comprises of connectivity. That already what we have seen in the slides, right? Sense, SE and SE. They have given in much more in-depth manner with respect to the technical terminologies, right? Connectivity, which is given in the white color text boxes. You for the time being you leave it. Don't get confused, right? Which is being represented in the white color text boxes. You please leave it. Remaining will concentrate. That is connectivity, processor, audio video interfaces, IO interfaces, storage interfaces, graphics, and memory interfaces. See here, IO interfaces for sensors. Input output interfaces means directly it connects to the sensors, right? Interfaces for internet connectivity. Interfaces we need, either it may be audio video or storage interfaces. Storage interfaces for storing. Audio video means either in the form of audio or video, some text message, what is the way in which we need to get it. These are for interfaces to the corresponding IO of the sensors. Then memory and storage interfaces. Memory and storage interfaces are for storing and retrieving. Audio window interfaces. See here, this is the way in which the generic block diagram of IoT. Generic means very traditional, the basic. These are the very basic requirements that has to be incorporated in any IoT as a building blocks, right? See, this is the IoT protocols that resides in the corresponding layers. This is the IoT protocols that resides in the corresponding layers. From down, if you are seeing from in the with respect to the diagram, link layer, network layer, transport layer, and application layer. I repeat, link layer, network layer, transport layer, and application layer. Whereas in the diagram, it comes from where it is being connected. In the diagram, it shows that from where it is being connected, right? In the link layer, what else the protocols are available? See here, there are 4, 5, 1, 2, 3, 4, 5. That is 802. These are IEEE standards. 802.3 means Ethernet, wired. 802.11, that is Wi-Fi, wireless connection. If I want to go with much more lengthier with stronger data, then 802.16, that is WiMAX, Wi-Fi with maximum capacity, right? Then 802.15.4, then again lower it with the devices which consumes less power, which is having a capacity of low power with somehow the long ranges, LRW plan. Then much more storage devices with higher capacities, 2G, 3G, 4G, right? This all with respect to the link layers. Coming to the network layer, what is the way in which I can refer the data in network layer, that is IPv4, V6, and low power WPAN, right? In transport layer, either with a TCP connection oriented or connectionless, TCP or UDP. With respect to application layers, these are the various protocols which is applicable in application layer for communicating to the corresponding applications, right? Sttp, CoAP, WebSocket, MQTT, XMPP, DDS, and AMQP, right? See, right now, we in the earlier slides we saw some examples about IoT building blocks, all generic applications of IoT, right? Whereas here, with respect, what else the protocols are applicable or available to proceed with IoT? That's what we are going to see. Somehow it will be very hard to understand in the initial level itself. Please don't think that I'm putting you in trouble. It is not like that. For the first time, it will be somehow difficult. If you are go through the same slide for twice or thrice, after that, the same slide is available in the internet also. If that is the case, then you will get much more understanding about the protocols of IoT, right? I'm proceeding to the next slide. With respect to, see here, now what we are going to do is, in IoT protocol, in the link layer, we are going to stage by stage, right? Where it is being connected. Now it's time to link up with the very basic example of sense, SEN, SE. If you are, could not able to follow up, again I will recollect. Now we are in slide number 55. I'll go to sense because it will be very easy for you to, yes, see here, sense. What means sense? Leveraging sensor to generate context data. First I need to contact on the data. That's what that link layer, where the sensors resides, you need to collect the data, right? Efficient way, it enhances efficiency in productivity terms by adding intelligence to things. That means collecting the data should be efficient manner, right? After efficient manner, then it has to be communicated. That is network, creates a network of things. For that network layer, IPv4, IPv6, and 6 low. That is, the 6 represents IPv6 with low power WPAN. We'll see in depth, right? Then specialized ultimate use is focus on domain-based specialized offerings. That means then it has to be communicated. That means from network layer, transport layer, that is either through connection or connectionless, right? Then everywhere else. That means based on the environment, based on the application, based on the scenario, it varies. That's what the application layer, right? You got it, right? Now I'm just thinking of the same. What else the IoT you are working on, it ends with or it represents with sense, right? This is a very useful word. Please remember it. It will be very easy for us to remember and recollect, right? Now Yes. Now, IoT protocol, in that IoT, first link layer, in that link layer, we are processing to 802.3 Ethernet. See here, IoT protocols, link layers in that Ethernet. See, these are the various options available: 802.3, 0.3.I, 3.J, 3.AE. It is very hard for us to remember all those things, but to do some research, we can concentrate more on the application layers where we work on, right? Because it directly, if you are working with the link layer, or if you want to do that, means it directly goes with the relates with the hardware. Then we need to know or explore more about the concerned hardware, right? 802.3 coaxial cable, 10 base 5, whereas copper twisted wire is being represented 802 3.I. See here, in those link layers, the data rates are provided from 10 gigabytes to 40 gigabytes and higher. The specification range, how it does or what it does. Then accordingly, if you are going with the, when compared with the coaxial cable, copper wire is much more costlier, and the data transmission rate will be that much reliability is increased. When compared to copper twisted wire, fiber optic is very costlier, and also as well as it can have very good speeds. Then if you are going for fiber optic with more connectivity, that is, even in our colleges, we might be seeing that from where the data is being receiving from the receiver to the server room and to the exam branches. If you are seeing, for example, I'm saying to the exam branches and all will be connected through directly through fiber optics, such that the reliability, data transmission fast, and security has to will be ensured for ensuring that. Whereas to the going with a normal copper twisted wire or even with a coaxial cable with, which is connected through RJ45, we can use it, right. This is with respect to IoT protocols, link layer, and using Ethernet. Coming to the Wi-Fi, see here, much more speeds you will be getting. Whereas it has been represented as 802.11a, 5 gigahertz, then 2.4 gigahertz, 2.4 to 5 gigahertz, 5 gigahertz, 60 hertz. Then see here, the maximum speed what we will be getting is 5 gigahertz. Collection of wireless LAN, that is said to be as Wi-Fi. Whereas earlier one is Ethernet through connected wires. This is wireless connections. The data ranges from 1 Mbps to 6.75 Gbps at the maximum. Coming to the link layer WiMAX, here wireless broadband standards. That is, see here, we can able to see the speeds. This is what mostly we will be preferring in our laboratories, right? It's the corresponding standards is 802.16 m, and the data rates ranges from 1.5 Mbps to 1 Gbps. Whereas in the same link layer, LRWPAN, low rate wireless personal area networks. That is low rate. The range of speeds won't be that much higher. Mostly it will be in the range of kbs, that is kilobytes, right? And it is mostly used for, as the name itself indicates, LR, that is low rate wireless personal area networks. It is used for low cost and low speed communicating devices where the power constraints are more. That is, it cannot be able to retain the power for more time, such that since because of those constraints, it is used or it is restricted for lower or slower devices and low power rates, lower data rates, right? Coming to the link layers of 2G, 3G, and 4G mobile communications, right? GSM, this GSM already we know it, right? Right now, what else we are using it? Global system for mobile. Then CDMA, code division multiple access, where such that the same division or the same code is being accessed for multiple access. Then UMTS, Universal Mobile Telecommunication Standards and Systems, right? Then LTE, as of now, all geo users will be knowing LTE, right? Long term evolution such that where somehow it goes with higher speeds of data. 2G, 3G, 4G. As of now, we have, and 5G is being introduced in a few other countries, but we yet to receive in another. Sorry, we don't know. Either it may be in another couple of years we'll be getting it. Then whenever you are going for higher ends, then the data rate, see here, 9.6 kbps for 2G up to 100 mbps for 4G networks, right? This is what up to link layers, IoT protocols in that to the link layers. See here, just as summary, I am going back. 802 Ethernet, Wi-Fi, WiMAX, LR, low rate, wired personal access numbers, devices, and 2G, 3G. This is what the link layers. Coming back to the network or internet layer, we'll be having IPv4, IPv6, and 6 low WPAN. Now we'll be seeing this network layers. Network layers. See here, network or internet layer. In some authors or some devices or some environments, or what in that the network layer can also be represented as internet layer, right? It is responsible for sending of IP datagrams from source to destination, that is sharing the data or communicating the data from the source to the destination. Performs the host addressing, then host identification done using the hierarchical IP addressing scheme such as IPv4 or IPv6 based on the number of devices is being currently used. IPv4 uses 32-bit addressing scheme, whereas IPv6 uses 128-bit addressing. So you see here, or even if you are going for 6 LOWPAN means, see 6 stands for IPv6 protocol, that is LOW means low power wireless personal area networks. For example, in your the best example if I want to represent means, in the mobile itself we can enable mobile hotspot, right? Device or hotspot. In your mobile you know it, whereas if you are coming to the laptop, in your home, your laptop is connected through Wi-Fi, or else it may be connected to even through wired system also. Whereas in the latest Windows 10, Windows 8 and all, prior to that, we cannot make it. Whereas if your laptop is enabled with the Wi-Fi, then even you can able to convert that laptop itself into a hotspot device such that from laptop we can able to connect up to 8 devices from laptop, right? That's what low power in those scenarios. Whenever the number of system increases, the battery drains is directly proportional to each other. That means more the devices, the battery drains earlier, right? Like that's what the best example for low powered wireless personal area networks I'm saying, right? So the same uses IPv6. That's what that first 6 represents. See here, this 6 LO represents low power WPAN, right? Wireless personal area networks. Used devices with a limited processing capacity, operates in 2.4 GHz, data rates of 250 kbps, right? This is with respect to network layer. With respect to transport layer, provide end-to-end message transfer capability independent of underlying networks, whereas it provides with options such as error control, segmentation, flow control, and congestion control. That means whenever the data is being transmitted, it ensures the security. It ensures the security by either enforcing the error control or flow control or even the congestion control, right? With respect to TCP, as already we know that TCP is transmission control protocol with wired access, right? With connected, right? So with the connection oriented, with the connection means directly it ensures the reliable transmission, and it ensures the error detection capability, it ensures the control capability, it ensures the congestion control capability, right? That means the best example is being represented in the diagram. Are you getting all of this? Whether you are getting all the data, if not, it has. If the connections, if the receiver is not up to the level of receiving all the packets or the data, then it informs the sender stating that it could not make it or little bit you can slow, so that I will be getting all the data. Accordingly, this is what we call it as handshake mechanism. Na? The sender and the receiver are synchronized to each other such that the data transmitted is reliable and secured, right? Whereas with UDP, with respect to user datagram protocol, it is connectionless. It doesn't ensure reliable transmission. It does not connecting or does not do connection before transmitting. Does not provide proper ordering of messages. It is a responsibility of the receiver to reorder the data. That means, are you getting all of things? The sender will be sending. Who cares? Just to send it faster. That's it. This is the terminology of receiver, and after receiving, it is the headache of the receiver to rearrange the diagrams. Sorry, not the diagrams, the datagrams, and process accordingly. If not, it has to send a request to the sender stating that again the data has to be resent again, right? Transaction oriented and stateless, right? Whereas see the conjunction, this is state, whereas the TCP is state oriented. That's what all the banking transaction, online transactions are maintains a session, right? Whereas UDP and IO protocols, application layer, hypertext transfer protocol. I need to go back earlier, just a minute for recollecting. See here, As of now, we were here. Link layers, we have seen these 5 layers with respect to network or internet layer. We have seen IPv4, IPv6 and 6 low wireless personal area networks. Then transport layer with respect to TCP and UDP we have seen. Coming back to the application layer, we are going to see 7 protocols ranging which has been represented here, right? To represent you that we are on track. I am just going back and ensuring the connectivity that whether myself and the participants are on track or not. That's it, right? I'm proceeding further. While traversing also we'll have a just recap. In link layer Ethernet, link layer Wi-Fi, link layer WiMAX, link layer low rate wireless personal area networks, link layer 2G, 3G, 4G networks. In with respect to network and internet layers, network layer IPv4, IPv6, 6 low PAN, then transport layer TCP, UDP. Coming to the application layer, 6 layers, 6 protocols we need to see, right? The first and foremost thing is hypertext transfer protocol, hyper transfer protocol, right? It includes commands such as get, put, post, head, options, trace, etc. It uses universal resource identifier or locator. URI, URL will be representing the uniform resource locator, universal resource identifier. URL and URI is used in the World Wide Web to specify or to identify or to locate a particular file, right? That is said to be as hypertext transfer protocol, or in short, they are represented as HTTP, right? It uses commands such as get, put, post, head, options, and trace. All they are having a separate and specialized options. For example, if you want to see the data which is being transferred from a page to the next page, then we can go with some sort of options. If you could not see, if you don't want the user to view it, for example, in online transactions and all, in online transactions or in very basic example, if you're in Gmail, if you are clicking as inbox, by default after logging in, it leads to inbox, right? If you want to move to any other folder or spam or trash or even sent mail, if you are clicking on it, directly you can able to see the changes in the URL, right? So stating that what else the way in which you are traversing that will be applicable or that will be seen directly in URL. Whereas in banking transactions, what else? There are 2 options in banking. If you are keenly observing it, what else the pages you are traversing, what else the page you are traversing in the banking application, either you may not be seeing at all. The URL you won't see any changes. For example, you are logging into the State Bank of India means sbaionline.com alone will be seen, or sbaionline.co.in alone will be seen in the URL. What else the pages you are traversing in your dashboard or in your website, it won't be seen there in the URL. It will be seen only in that status bar or taskbar. Or that is option 1. Option 2 is whatever the changes be been there, it won't be disclosed to you at all. If it is disclosed only, then there is a possibility of hacking, right? To provide more security, the session or the page where whatever you are working on itself, they will be hiding. That's what the more, even though see here, if you are working with that sort of or that such sort of security issues also, most of them are even much more intelligent to hack it. That's what happening, right? Fine. Next, application layer, COAP, constrained application protocol. This is mainly used for communicating between the machines, that is machine to machine applications meant for constrained devices. Web transfer protocol for IoT and uses request response model. Request response model. Mainly it enforces client server architecture and supports methods such as get, post, put, and delete. Mainly it is used for machine to machine applications. It is represented as COAP, constrained application protocol, right? IoT protocols application with respect to WebSocket, right? Completely is based on TCP. It is full duplex. It is full duplex. That means both the client and server can communicate each other at the same time, right? Client can be a browser, IoT device, or mobile applications. Coming back to MQTT, that is message queue telemetry transport. It is a very lightweight messaging protocol, which consumes very less memory, and also as well as used to proceed with publish and subscribe model. publish and subscribe model. It will be generally applicable. Who else is interested for that particular application, they can subscribe and they can use it. Like watching YouTube channels, right? In YouTube, if you want to watch any other channel directly, either news channels means directly you go to the channel, subscribe it, and whenever they are posting a new screens or else a new videos, they are it is applicable directly. You will get a notification, right? That's what publish and subscribe. Whenever you are subscribing to that, and accordingly they are publishing, you will be getting notification or you will be notified, right? This MQTT, message queue telemetry transport, is much more suited for low processing device with low memory and lower network bandwidth. That is, whenever there is no that much of memory capacity and also as well as network bandwidth, we can go for MQTT protocols. Then XMPP, extensible messaging and presence protocol. It is mainly applicable for real-time communications that streams the XML data between network entities, right? Now what else we are using? No? There is a Google Meet, which is used for sharing the data for n number of users at different locations, right? The same used for applications such as multi-party chat and voice video calls. XMPP, that is extensible messaging and presence protocol. That means whenever one user is texting, it will be notified to everyone else, and even it provides a provision for texting individually, right? Then it is a decentralized protocol and uses client server architecture, right? Even if I want, if for example, why they are using here this terminology uses client server architecture means, if you want to share the screen, share your screen right now, immediately you can take over and you can consider it as a, you will be considered as a server such that whatever the data you are transmitting, everyone receives. Whereas the application differs. Whereas if you are going for Zoom, the same, unless otherwise a particular host is making other as a host, you can't activate you as a host. Whereas in Google Meet, they have given a provision such that for easier sharing of data, everyone, the n number of users, whoever may be the n, they can start sharing immediately by sharing their screen. For example, I'm saying, since because we are much more comfortable with the Zoom and Google Meet right now, right? Then DDS, data distribution service. Here it is a data centric middleware standards, right? And mainly used for communicating the data between the devices and device to machines, and mostly it provides the quality of service. It provides the quality of service with reliability, right? And publish subscribe model, where publish creates topic to which subscribers can use. The same option which is been given earlier, but the speciality of DDS is that it provides quality of service with a reliability, right? The next one is AMQP, advanced messaging queuing protocol, mainly used for business messaging. Same like one to many. Now you might have seen with the WhatsApp business account, right? The same data can be shared to n number of users. Either n may be even there is no limit at all. If you are going up with a business account, that's what. Advanced messaging queuing protocol supports both point-to-point and publisher subscriber model. The examples we'll see later. What is point-to-point and much more diagrams are there. Sorry, since this can be represented only with the text, I'm going on doing this. Later we'll come up with much more diagrams for the examples. Publisher and subscriber models, routing and queuing. Here, broker here receives messages from publishers and route them over connections to consumers through messaging queue. The broadcast message only, the same message is being communicated to n number of users provided they are subscribing. Provided they are subscribing, or else once they are subscribed, you will be notified and accordingly you can receive the data, right? AMQP is advanced message queuing protocol. Now it's time to go back to that IoT protocol. What else we have seen? These are the protocols available. Just I'll show you. See here, all the protocols we have seen. Link layer in that 802 Ethernet, 802.11 Wi-Fi, 802.165 Max, 802.15.4. Low rate wired personal area networks, then 2G, 3G, 4G. This is with respect to link layer. With respect to link layer, with respect to network layer here, with respect to network layer IPv4, IPv6, and low powered wireless personal area networks, which uses even IPv6. Coming to the transport layer, TCP and UDP. Coming to the application layer, Sttp, coax, WebSocket, MQTT, XMPP, DDS, and AMQP. All these. What else being represented in the white color boxes being represented right now, discussed, right? are moving logical design. Here we will be seeing some levels. How for as of now we have seen this sort of protocols. Now we will see some examples where it is being applied or what the diagrammatic representation how it goes. Right? See the device, it communicates with the corresponding services, with the management and security, the corresponding application from device, how the data is being collected by the device and given back to the application for further processing. Right? See, an IoT system comprises of number of functional blocks. Here only we have shown you 6, right? It comprises based on application, the 6 can be comprised into 3 or it can be expanded into 10. It is completely up to the environment where we are working on, right? Provide the system that capabilities of identification, sensing, activation, communication, and management, right? See here, logical design of IoT. For logical design of IoT, we need to ensure these 6 points. That is, first one is device. Device is sensing, activation, monitoring, and control functions. Then communication through IoT protocols, what we discussed now. Then services like device monitoring, device control services, data publishing, and device discovery. How we are going to provide services through these protocols. Then management, functions to govern the system, how we are providing the security and how we are managing the data, right? Security. Functions such as authentication, authorization, integrity, and security, right? At last, the application. Once the collected data through IoT protocols, it has to be communicated, it has to be managed with security such that it is rendered to the corresponding application, right? Yes. It comes to the implementation now. We will see some practical examples how these IoT, the communication, as of now we said, right, the logical design of IoT from the device to the applications, from the device to the applications, how it grows, how it goes, what else the way in which we can share the data starting from gathering the data to the application, right? The first and foremost thing is request response communication model, right? See here, due to the time constraint, just slightly I will be pushing up. Just I will be explaining the diagram and I will be moving up. Right. Still much more diagrams are there. Right. It is a communication model in which always the client sends a request to the server and server responds to it. As the name indicates, see here, client request and server response. What it will do? Receives request from the client, process the request, looks up, prepares the response, and sends request. For example, Gmail account, username, password. You are giving, you are logging in with your username and password. If the password is correct, it leads to you the inbox. If not, it comes up with a bad remark or bad gateway or some errors, right? The corresponding resources. What else you are requesting? Either you are moving to trash, you are spam, you are reading some mail, you are attaching some content, you are deleting. What else option you are making it based on the client request, the server response, right? Coming to the publish subscribe communication model. Here, it is a communication model that involves publisher, broker, and consumers. See, the name itself changed. Earlier, client server resource. The color doesn't change. See here, if you are seeing the color for client, it is orange, server it is green, and resources it is blue. Right. The concept slightly upgraded, and the terminologies are changed. See here, the client color is same as that of publisher, and the server color is same as that of broker, and resources is same as that of consumers. Now, since the publisher, what he will do now? Message published to topic 1. Accordingly, what they will do? This broker. Here, I want to represent one word called as CORBA, CORBA in Java subject, right? Could you able to recollect the terminology here? Common Request Object Broker Architecture, CORBA, right? Whereas here, this publish subscribe communication, what it does is that involves publisher, broker, and consumer, right? Here, the source of data is a publisher, and it sends the data to the corresponding broker. And publisher or not publisher, this publisher is there na. This publisher is not at all aware of consumers. Publisher is not at all aware of consumers, whereas consumers directly subscribe to the topic managed by the broker. For example, YouTube. There are n number of channels. From that channel, what else you are subscribing a particular channel? In those channels, you will be getting notifications then and there, whenever the updates are made. Got it? Likewise, see when the broker data or receives the data, a particular topic from the publisher, it sends the data to all the subscribed consumers. See, for the topic 1, subscriber 1 and 2 means the same, it will be communicated. Whereas topic 2, only consumer 3 alone subscribed. So it will be shared to them alone. If you are subscribed for n number of channels, you will be notified for those n number of channels alone. Except that you won't be getting notification for n plus 1 channel, right? This is what Sttp has published subscribe communication model. The third one is push pull communication model, right? Here the data producers push the data, publishers push the data to the queues, and consumers pull the data from the queues. Here, since my publisher directly see here, the color doesn't vary at all. Publisher, broker, and consumer. Instead of broker, they kept in queues. Directly, all the data will be moved to queues based on the requirement, based on the speed, based on the capacity. The consumer will be going on fetching the data from the queues. That's it. Based on the requirement, if the queue wants to be added or it is getting filled up means, then the queue capacity has to be increased or the buffer has to be increased either in the publisher side or else in the consumer side. These are the various ways in which the data can be collected from the IoT for further processing, right? Then exclusive pair communication model. This is exact handshake terminology. TCP model, right? Request for setup connection. Once done, response. Message from client to server, message from server to client, connection close request, and connection close response. For every transaction, for before sending the request, before sending the data, client request server, whether you are ready or not. If the server responds, then client started sharing the data. Once completed, the server also gives authentication or stating that the communication to the client stating that yes, I received the data. Once done, client initiates the closing request. Accordingly, the connection is closed. Right. This is the perfect TCP connection, that is exclusive pair communication model. Right. Through connection setup only. Right. REST-based communication APIs or EST. This is mostly used in IoT as of now in the current scenarios. REST means representational state transfer. Representational state transfer. It is a set of architectural principles by which you can design web services and web APIs. Right. Most of the content. For example, very basic example we want to represent here is even you can switch on and off your AC through mobiles, right? You can switch on and off ACs through. You can switch on and off motors through ACs through your mobiles itself. The same case here. Wherever the corresponding devices are, the device has to be connected to with either with a short distance means either with a Wi-Fi. If it goes with much more long distance, then 2G, 3G, 4G, it applicable. Based on the distance only. Again, we have seen multiple link layers, right? That's what. Here, REST-based communication, it is an architecture principle by which you can design web services through internet. We can directly connect it, and web APIs that focus on system resources and how the states are being transferred, addressed and transferred. Mostly it follows with request and response communication. Request response means exactly, again, request response for the first model, right? See here, first HTTP client, right? It through the packets, HTTP packets, it can communicates to HTTP server. From the server, directly the corresponding resources, what else the resources are available. Based on the client request, the corresponding resources are fetched and being processed. Right? REST architectural constraints apply to the components, connectors, and data elements within a distributed hypermedia systems. Since the data is being shared across the network, the privacy plays a major role. That's what the constraints applicable are the components, connectors, and data elements within the distributed hypermedia systems. See here, REST-based communication API constraints. That is, it follows the client-server model. It is a stateless and cacheable layered systems, uniform interface, code on demand. Always based on the client request, the server response. That's what. Based on the client request, the server response. That's what representational state transfer. that is called as REST or EST, representational state transfer. Just a minute, please. Yes, WebSocket based communication APIs, WebSocket based, right? Here what it does is allows bidirectional full duplex communication between clients and servers, right? Follows the exclusive pair communication model. That means all for a particular request, if the for a client request, the server has to respond. Based on the response from the server, the client initiates the subsequent request. That is said to be as exclusive pair communication model. Right? I repeat, based on the server's response, the client provides or initiates the corresponding request. If not, it again waits for the concerned response from the server. Right. For example, see here, in the client request to set up a WebSocket connection, right? It waits. When the response accepting the request alone, then data frames are being sent from the client, then acknowledgement data frame, then acknowledgement. See here, bidirectional communication over persistent WebSocket connections. Directly, these two machines are connected to each other, right? Unless otherwise, the corresponding response is not received from the server to the client's request, then it won't initiate further processing. That's why the WebSocket protocol, and it is bidirectional. It is bidirectional with full duplex communication, right? Then once all the data frames are being transmitted, then connection close request is initiated by the client. For the concerned connection close request, the server's response once we are being get or received by the client, then the connections are closed. That's what see here. Initial handshake, that is over HTTP, it will be done for initiating, then data transfer. Once the data transfer is done, the connection is being closed, right? Then the difference between the REST and the WebSocket, difference between the difference between the REST and the WebSocket based communication APIs. See here, comparison based on these are the features 1, 2, 3, 4, 5, 6 features we have taken for comparing the REST and WebSocket. REST means representational, already we saw the representational state transfer, and the other one is WebSocket. See here, it is a stateless and stateful. The first stateful is much more uh, advantageous and secured when compared to stateless. The REST is unidirectional, whereas WebSocket is bidirectional. This is an exclusive pair model, follow request response model, whereas with respect to WebSocket involves a single TCP connection for all requests, whereas each HTTP request involves setting up a new TCP connection such that it takes more time for us to ensure it. Whereas with respect to WebSocket, it is like a dedicated link. That's why the bidirectional link or full duplex link is becomes very easier with respect to WebSocket. Does not involve overhead of headers because only one connection, right? Since because only one connection, once the connection is established, directly transmitting or transmission of data starts. Whereas that's why that does not involve overhead of data. Only first and last we needs to be ensured for initiating and closing. Whereas for every request, the HTTP header has to be carried with the packet numbers, security numbers, and the corresponding data. Whereas only vertical is easier, both horizontal verticals are easier, scalability, right? Right. These are the comparison with respect to even these are the environment where we can concentrate more on doing our research, right? Some IoT enabling technologies, wireless sensor networks, cloud computing, big data analytics, embedded systems. Now we will look into the IoT levels. There are 5 to 6 levels are available. In that, just we will have a glance on what basis these levels are categorized, right? For all the 6 levels, 5 to 6 levels, these are the components available in generic or in general. First and foremost thing is device, that is allows identification, remote sensing, activating, and remote monitoring capabilities. These are from where the data is being gathered. Second one is resources, either resources or software components on IoT devices for accessing, processing, or storing the information, right? Either it may be of software components for just for connecting the devices such that the data is being shared from the environment where it is being collected to the desired location. That's what resource mean here, right? That is, device is the actual sensor where the data has to be collected, and resource is from the collected data from the sensor, the data collected data has to be transmitted, right? And while transmitting, it has to be ensured with security. For that, the controller service is a native service that runs on the device and interacts with web servers, sends the data from the device to web service, and receives commands from applications for controlling the device. That's what the last word, the controlling the device. That is, from device we are gathering. After gathering the data, it has to be transmitted or it has to be shared. While sharing, some controlling mechanism has to be there. That's what the controlling servers does. The fourth one, database. After collecting the data, it has to be stored either in the store if you are with a local machine, or else you need to store with a cloud storage, right? Then after that, if you want to go with communicating that stored data in the cloud to some other locations for analyzing it, then we need to go with a web service, analyze component, and the corresponding application to be notified, right, to the system or to the user. What else? The way in which the user has to be notified in a better understandable manner or better easier manner, right? For that application, for analyzing component, right? Then web services, which uses HTTP or the REST protocol, or else even the WebSocket services for linking the IoT devices to the corresponding analysis components, right? For all the IoT levels, what we are going to discuss right now deals with this 6 to 7 points. That is, device, resources, controller services, database, web service, analysis components, and applications, right? This is level 1. See the diagram, right hand side, you can able to see the diagram, right? Level 1, which is being categorized into 2 categories. One is local, another one is cloud. Whereas see here in the local, the application, REST WebSocket services, controller services, resources, and device. What else the concept we are seeing now? See here, device, resources, controller services, database, web service, analysis component, and application. All these 7 words which is being bold here, these are the IoT systems comprising of corresponding components. These are the components of IoT levels, right, which comprises to form much more different categories of levels. That's what we are going to see. IoT level 1. See here, devices, resources, controllers, web services or web sockets, then corresponding applications, right? In between these two controller services and REST services, we have databases. In IoT level 1, there is no need of cloud at all, right? Here the monitoring node performs analysis, stores the data. Here from where we are getting the storing, retrieving the data. The level 1 has single node or a device that performs sensing, stores the data, performs analysis and host, and the application. Where it is being used? These are used or applicable for low cost and low complexity solutions where there is no need of much more analysis and need of much more computational intensity is not at all bothered here, right? See here, from the device the data is being collected to the resource, from resource the controller services, from here the data is stored, from data WebSocket services, then directly it is given to the application. With respect to level 1, all the transactions takes place only at a local point. No need for cloud storage. Where I am using this, right? See here, home automation systems. This is exclusively used in home automation. See here, one control panel is there. One control panel is there. In that control panel, directly all the devices, either sensor for mailbox or doorbell, intrusion detection, electric pot, electric stove, or air conditioner, water sprinkler. That is either the washrooms or even in the gardening, maybe the environment. Then smoke detector, lighting control, all are. See, which is in the blue color is Ethernet, directly they connected through the devices. Then IO signals based on the circuits, what is the data we are collecting it has to respond. There is no need of any specialized cloud storages, and from where the data is being collected based on the data, it works. This is level 1 IoT, right? Coming back to the level IoT level 2, partially see the storing of data and processing happens at cloud. You can able to see the difference. See here, an earlier example, there is no the need of cloud storage and all things happens at the local level, that is home automation system. Coming back here, see here, it is a single node that performs sensing and activation at some local analysis, local part. See, the data is stored in the cloud. With respect to level 2, the data is stored in the cloud, and the application usually a cloud-based form. Right. Where it is applicable, it is suitable for solutions where the data involved is big, somehow big, and however the primary analysis requirement is not computational intensive and can be done locally. Primary requirement analysis is device, resources, and controller services can be at local places, and the remaining where the data cannot be stored at the local is being moved to the cloud, and where the processing takes place. Right. Then the real-time example of IoT level 2 is see here, smart irrigation. Smart irrigation. That means smart agriculture will be saying that the temperature has to be monitored, moisture, pressure, health, and health of the crops and connectivity all are being checked at remote locations, such that from there, after collecting the data, it will be stored in the database which resides in the cloud, such that whenever it comes into the terminology, the cloud, we can access from anywhere else. That is, irrespective of my location in my form. I repeat, irrespective of my presence, irrespective of my presence in my form, I can able to monitor and control the watering or the temperature based on the crop's health. Right. Coming to the IoT level 3. Coming to the IoT level 3. It is a single node. Data is stored and analyzed in the cloud again, as said in the level 2. But what is the need for level 3 is it is involved in big and analysis requirements or computationally intensive. Very similar to level 2, but where here when compared to level 2, level 3 it comprises much more computations. If you see the diagram, see here in a database directly from server controller server to from controller services. Here we'll be moving to REST WebSocket. From the database we'll be processing, right? Whereas see here the same process, somehow we can have the copy of the WebSocket communication between the controller and also as well as the apps here, such that it retrieves or it involves, not retrieves, sorry, it involves more computations when compared to level 2. Then where it is being used, or sensors are used, accelerometer or gyroscope, that is mainly is used in tracking the packages. For example, whenever you are placing an order in Amazon online, from the day of being dispatched or immediately after ordering also, if you can able to see that online tracking the package, that packing is going to dispatch or ready for dispatch, the wordings will be going on changing. Once done, it is dispatched means the timing wise you can able to track the items what else you have ordered, right? That sort of tracking can be done with the help of IoT level 3, right? IoT level 4, it has multiple nodes. Earlier at all we have only one node. We have for monitoring node from where only one data is being processed, where only one data is being processed. Whereas coming here, we with respect to or starting from level 4, we will be collecting data. We'll be collecting data from more than one node or multiple nodes are there. As stated earlier, from level 2 itself, the cloud storage requirement is more, and here the level 4 contains local and cloud-based observer nodes, such that which is used for ensuring the security. Right? Level 4 systems are suitable for solutions where multiple nodes are required. I need to collect data from more nodes. The data involved is big, and accordingly, when the data is big, that's what we will be representing as big data. Or again, since because of big data, analytics falls also more. Right? Where it is this sort of IoT levels are being used here, sound sensors or noise monitoring from different places. That is either roadways or in the landways itself, roadways or railways or even from airways. What is the wing being done, or temperature monitoring, or how the weather is being affected. All those things can be done with the sort of examples. Right. Coming back to the IoT level 5. As a multiple n nodes and one cloud coordinator node. Here the observer node is there, right? Observer node, it controls both the local and also as well as cloud, right? Apart from that, here analytics component plays a major role. See here, this analytics component, IoT intelligence is being integrated, and earlier it won't be there. Or see here, earlier here, REST WebSocket communication alone is there with respect to level 3. Moving to level 4, here itself the IoT intelligence started. Whereas coming here again, IoT intelligence here it plays a major role such that the analyzation helps to predict the forthcomings, right? Data stored, analyzed in the cloud and application. Here, both the data is being stored at the both local and also as well as server, are suitable for solutions based on wireless sensor networks in which data involved is big and analysis requirements are computationally intensive. Here, massive computation and data. Since because of massive data, we'll be going with massive computations and vice versa, right? See, level 6. The same, the diagram goes up again and again. That is, more the higher the level, higher the complexities. Higher the level, higher the complexities. Here, apart from that, here one more terminology. See here, what else the point we need to monitor or control or have a glance or provide importance is that observer node. When, right, observer node. Another one is IoT intelligence. When compared to level 5 to level 6, then centralized controller takes place a major role. Centralized controller, such that the local and cloud differences or overall monitoring, overall security monitoring is being ensured or taken care by centralized controller, right? Yes, these are the different IoT levels. Back to the previous slide. Yes. IoT protocols, levels, and deployments we have seen. We are moving to IoT architecture next. Security and challenges we need to go. Prior to that, what else the layers we have seen now? Right now, the IoT protocols and levels we have seen. Right earlier, just I want to show that protocols page. Yes, these are the different protocol levels we have seen. Right, link layer, network layer, transport layer, and application layer. Based on the requirements, and the scenario, we'll be categorizing or we'll be segregating into the number of layers. That's what been shown here. You can see here. So, yeah. IoT architecture layers. That is either 3-layer, 5-layer. Again, the 5-layer can be categorized into two types. This one again. These are the different layer applicable layers in IoT based on the requirements. 5 layers, 6 layers, and even 7 layers and fog layers. All right. This is being represented by this paper. As already I stated, for every diagram and the content from where is being cited, from where is being presented, I have given the citation on the last line or the bottom of the page, right? Because as stated, it should not violate copyright issues, right? Fine. Just an overview will be somehow will be rushing up because, madam, we have time, right?
Yes, sir.
Yes, it will have. I need another 10 to 15 minutes,
Okay, sir.
right?
Okay.
Yes, madam. Thank you. Thank you. Whether it is audible and the contents are seen clearly, now, madam. Is there any other issues?
No, sir. No issues, sir. It's going fine.
Fine. Thank you, madam. Thank you.
Okay. Okay.
Yes, architecture layer, the roles and functional features of 3-layer architecture. As the 3 layers, for better understanding, just for the corresponding layers, see, for the 3 layers, I have just cropped and kept it on the right hand side so that for easier understanding, it will be nice. Perception layer, network layer, and application layer, right? With respect to this 3 layered architecture, what it does, the first layer is perception layer, right? What is the main objective of this particular of this layer is to sense the capability or sensing the capability, that is collect and gather data. That is the responsibility of the network layer is to enable the transmission, that is what else the data is being collected from the perception layer, it has to be transmitted in the subsequent layers or the subsequent devices, right? Then application layer, its main feature is to deliver the specific service based on the applications, right? Always the application layer resides at the user end, such that based on the user requirement, it has to be displayed in the customized manner, right? Whereas the perception layer means it is at the data generating area where the sensors are located, from where the sensors are located. That means those are data generating scenarios or the data generation parts. These two, perception layer and application layers, are connected each other through network layer where the transmission is being done, right? Coming to the next 5-layer architecture, there are 2 5-layer architectures. This is one. That is, the first one is perception and layer, second one is transport layer, processing layer, application layer, and business layer, right? Whereas, see the perception layer here, what else we have seen with respect to the 3-layer architecture, network layer and application layer, its responsibilities remain same in all the subsequent architectures, subsequent layered architectures. Either if you are going for 7-layer architecture or if you are going for 5-layer architecture, the responsibility of application layer is to deliver the specific service. That's it. The responsibility of perception layer is to sense the capability. That's it, right? The application of network layer is to enable the transmission from the previous layer to the subsequent layer. That's it. Either using through UDP or TCP. What else we have seen earlier, right? Whereas here, the perception layer, that is sensing capability. The application layer here, it is deliver the specific services. Whereas in between, transport layer and processing layer. What is the transport layer? It is the responsibility of transferring the information, either through wired or wireless, right? If it is wired, means a corresponding wires link layers has to be Ethernet card has to be done. If it is wireless, then wireless Wi-Fi or WiMAX has to be used. Processing layer. Processing layer means it is used for storage, storing the data, analytics, and mainly used for getting the thorough knowledge about the data for further processing, right? Whereas the business layer, it manages the entire IoT system where the business and profit models is the user-friendly way with privacy. That is, here the business layer monitors and governs the control of all the earlier layers such that it ensures the user friendliness and security with along with the privacy, right? This is the one way of 5-layer IoT architecture. Other way of 5-layer architecture is or comprises of application layer, sensing layer, communication layer, service layer, and infrastructure layer. And infrastructure layer. Right. Whereas earlier, see here, perception layer, transport layer, processing, application, and business. Whereas coming here, application layer, it is used for collecting the information here, and various talks are to be done as a part of client requirements. Sensing layer allows an interaction between the previous application layer to that of a subsequent layers. Communication layer, it acts as an information bridge. That means it acts as an information bridge between the sensing and the service layers. That means collecting the data and processing it. That means the network layer responsibility is taken care by communication layer, as the name indicates, right? Then service layer, it helps in performing the activities that are required by the client. What is the services that is required by the client, right? At last, the infrastructure layer, it provides this layer creates the service oriented technologies like GIS mapping, cloud computing, big data, cognitive computing, storage facilities. As the name indicates, that IaaS in big data we will be seeing that IaaS, infrastructure as a service. That infrastructure layer, it provides all the service oriented technologies, right? Coming to the 6-layer architecture. Where it comprises of tier, focus layer, cognitions layer, transmission layer, application layer, infrastructure layer, and competence business layer. Coming back, see here, focus layer, it helps in identifying the nodes. Cognitions layer, it helps in identifying or describing more about the sensing capability of the corresponding sensors or the objects, right? Here, the sensors, actuators, and data monitoring systems are used for collecting the data from the surroundings. Either, see here, why we are saying that either the sensor or actuators or data monitoring systems based on the environment. If I'm using, if I'm applying IoT in the agriculture domain, then I need to go for sensors. The same based on the threshold level, either the water management or the humidity management, or else even the crop health management. What else is in corresponding sensors required? Activators. If I'm fixing some WBAN, wireless body area network sensors into our body, when the blood sugar level goes beyond certain level, or it reduces beyond certain level, it has to be intimated to the doctor or a nurse or to a corresponding person for subsequent remedial actions immediately. Right. If it is BP means somehow to some extent we can check up. Whereas if the sugar level, or if a person is having both sugar level and also a sugar complaint, and also as well as the blood pressure, along with that any other complication arises, then it has to be given utmost priority, right? In those scenarios, then it goes with sensors, actuators, and data monitoring, or data acquiring and data monitoring systems. Transmission layer transmits the data from the sensor to the subsequent levels. Application levels responsible for collecting the data and showcasing to the user. Infrastructure layer deals with service oriented technologies as stated in the earlier slide. That is 5-layer architecture. Here also infrastructure layer is there now. It deals with service oriented technologies. In competence business layer, it is used for assessing the IoT systems. That's what the name indicates, competence business layer, right? This layer allows assessment of proposed IoT systems in terms of analyzing the business profit models and how the user friendliness is achieved without compromising the privacy and security, right? The last deals with the 7-layer architecture. Along with it, this has one more model called as fog architecture, right? Here application layer, application support and management layer, service layer, communication layer, network layer, hardware layer, environment layer. The new terminologies here, what else we are seeing is application support and management. That is, it provides a complete management control, right? Then communication layer, it acts as an information bridge. Already we saw in the earlier slides. Then the other new two layers are hardware layer and environment layer, right? Hardware layer is used to integrate all the hardware components, whereas the environment layer is used to detect all the objects which is working correctly or not, such that whether is there any discrepancy in collecting the data. If so, what else action has to be taken, and if it could be able to manage, you could be able to recollect one statement, the properties of or characteristics of IoT we have specified as reconfigurable or self-configurable, right? Whenever the data or a particular sensor is getting troubled to get the data, it has to self reconfigure it by itself, such that the data collection is seamlessly. It has to ensure that seamless collection of data. If not by some means or by any means, we need to reconfigure it, or at last we need to replace with the other sensors, such that the data collection should not be disrupted at any means, right? The last one is the data processing in cloud and fog based architectures. See here, the same 6-layer architecture. In what way the normal 6 layers? See here, transport layer, security layer, storage layer, pre-processing, monitoring, and physical. These layers are there now. Here the transport layer, you just see here how the fog layer works with this transport layer, security layer, storage, pre-processing, monitoring, and physical. Here, except the first and last one, the first one is transport layer, the last one is physical layer, whereas the remaining 4 are integrated into one layer called as a data processing layer, which is being termed as cloud layer in cloud layer architecture. See, cloud layer architecture has only 3 layers. One is network of things layer, that is from where the data is being collected and passed to the higher layers. Whereas the security, storage, reprocessing, and monitoring, all these 4 layers activities being taken care by only one layer called as cloud layer. That means the responsibility of cloud layer and these 4 layers in the cloud and fog layer are taken care or represented as data processing. Right? With the security has to be ensured, it has to be stored with pre-processing and monitoring the layer. Or this is what is the collection of data processing. Right? By combining all those things, an improved IoT layer is being proposed to to ensure the security and privacy. The same, see here, the sense has to be done. SENSE, the first slide in the initial stage we have seen storing or getting the data. Sense, could you able to recollect? Right now we are in 43 slide. Just I'm going back to refer that or to recollect that what that sense is. SENSE, sensing, efficient, networked, specialized, and everywhere. Just to sense the data, collect the data with efficient manner. It has to be networked. That it has to be communicated with specialized domains, and last everywhere the data has to be shared. Right. This is what for ensuring the sense framework in IoT. Moving to the slide. Yes, the improved IoT architecture is being represented. See here, the first and foremost thing, environment layer. One small case study I said, right? That's what being represented here. The how, what is the way in which we can do it? Includes object to be detected or places to be observed. The environment layer, the last one. The second one is hardware layer, sensors and other sorts of hardware used for detection. Right. Coming to the third layer, network layer. Either what else concepts or what else components will be using here? Gateways, routing and addressing, network capabilities, transport, and error detection mechanisms. Right. Whereas coming to the communication layer, either what else parameters we need to constrain or we need to concentrate on? Flow control, QoS, quality of service, with the reliability and energy optimization. Coming to the service layer, service storage and orchestra, then service composition and organization, virtual reality, IoT service, virtual environment services, service resolution, virtual environment and service monitoring. That means we need to provide service by all means. That's what to represent, right? Coming to the application support and management layers. First and foremost thing is quality of service. All the devices has to be managed. Then business process has to be modeled properly such that the privacy, security, and profitable ways has to be identified. Coming to the fourth point, business process execution, authorization, key exchange, trust, and identity management. See here, all these things. All these things has to be managed with respect to the application support and management layers at last. The application layer, application IoT application, where the last layer 3, 4, 5, 6, 7. Seventh layer is the layer where the user is interacting. Right. With this, one general scenario case study is being given here. See here, an end-to-end connection. How for all the 7 layers? See from first level, what is that? Environment layer. Na? You can able to see environment layer. The second one is hardware layer. The hardware layer. Third one is network layer. Network layer. Fourth one, communication layer. The fourth one, communication layer. The fifth one, service layer. Service layer. The sixth layer is application support and management layer. Application support and management. At last, application. See, application. These are the different layers. 7 layers. 1, 2, 3, 4, 5, 6, and 7. Right. At last, the hardware, where the corresponding devices has to be monitored. From here, the user is being working with. Right. For every transaction. For example, you are booking an online bus, or you are booking, or some you are working with the tracking a vehicle. As a police personnel, they want to track particular vehicle which is being hijacked, or a person is has to be monitored. Whatever may be the scenarios, this is an end-to-end interaction between the various layers with respect to the improved or minimum IoT configuration architectures has to be satisfied for proper data sharing. Right. See here, as a user, they are communicating with respect to the application support and maintenance. What it does, it maintains the quality, QoS, quality of service, device managers. It provides authorization and identity management such that the concerned user is provided permission to access the concerned data. Right. He should not be denied, or he should not be given more access for others' data also. Right. That's what. Coming to the services, what else the services has to be done? Virtual instances, corresponding resources allocations, what else is required? Analytics, virtualizations, or visualizations and IoT databases. For the corresponding data, what is being requested, it has to be allocated with the concerned resources, and it has to be monitored through the proper communication of IoT web portal. The flow of control and reliability has to be ensured. Coming to the network, all the network layers supports either wired or wireless routing concerned routing protocols. The corresponding networks are being linked up and with the so that the corresponding hardwares are given access such that the environmental scenario or the environmental data is being gathered and presented to the user. Right. This is how the architecture layer, IoT architecture layer. Here we represented 7 layers, no? Ranging from environment, hardware, network, communication, service, application, and application support and management layer to the application layer. The corresponding end-to-end transaction is being depicted here. Coming to the another one more example. See where it is being done, right? With respect to application layer, here it is reversed for even better understanding. Even we might have given with other way, but see in the earlier diagram, if you are seeing a application layer will be at the top and environment layer is at the bottom. That means the first layer. Whereas with respect to this example, application is layer at the end, and that means at the bottom, and the perception layer is at the top. You just have a look at this diagram. Application layer where the smart homes, e-health and transportations are available. Then coming to the network, wireless, it can be done with a wired or wireless. Whereas security layer, it is the responsibility to ensure with encryption, hash encryption or decryption. By any means, it has to provide security. That's it, right? Then with us coming to the processing layer, how the data processing, extracting the usual information from the data and remove unrelated data. That such that the big data analytics or the computation time can be reduced so that even the unrelated data or unwanted data might be need not to store in the database, right? Such that the observer layer, the responsibility of the observer is to authenticate the concerned user such that they will have given access right to process their data, thereby leaving others not to access their data, thereby ensuring the security and privacy. Right. Coming to the perception layer, RFID, WSN, and Bluetooth. These are the various options in which is applicable and available at the concern layers to provide the securities. The last session, the last topic, IoT, security and challenges. Here, the major challenges in IoT. The major challenges in IoT are first and foremost thing is heterogeneity of IoT data streams. As the name indicates, see here, heterogeneity. It is since the data is being collected from sensors and all the data are at different data types, as the term or the terminology indicates that heterogeneity, no other data is of with same data types. To work with or to moderate to cope up with the different data types, it is a major problem, and to work on, get the insights and accordingly act is very, very difficult. Coming to the second point, the varying data quality. That is, several IoT streams are noisy and incomplete, which creates uncertainty in the scope of IoT analytics applications. That is, varying data quality. That is, nowhere else without the providing the proper data or getting the right data from the database is very difficult, and we need to extricate the unwanted data or unrelated data alone by means or by chance. If you are extricating the required data, then for that you need to know that or explore that the data which is required and which is not required, right? By mistakenly, if you are omitting or deleting the required data and later on we are working with the unwanted data or unrelated data, then the entire processing becomes waste, right? Yes. Coming to the real-time nature of IoT datasets, then IoT streams feature high velocities and for several applications must be processed nearly in real time. Processing the data at real time is very, very, very difficult. With the local machines itself, we are getting this sort of issues. Then you just think about it. All the data related to the IoT, or the name indicates Internet of Things and Internet of Everything. The next subsequent level, it becomes all the data has to be processed in real time. Then it becomes very clumsy. So the concerned data, collection of huge data, processing it, again taking remedial actions with respect to the collected data, right? Then the time and location dependency of IoT streams. The time and location, as the name indicates, the time and location. With respect to the time, if it is related to agriculture somehow, if you are not watering the plants for 1 hour or 2 hour, no problem. After that, either instead of in the morning or afternoon, or instead of afternoon, the evening, you can water the plants, no problem. That too, for much more bigger plants or much more hardened plants, it is not necessary that it has to be planted daily, right? Whereas the timing criteria, the time and location dependency, if you are working with the real time data of patients, you just think about it. Whether with respect to agriculture, watering in the morning instead of watering in the morning, afternoon you can do as we said. Whereas the same action or the same process cannot be applicable with respect to healthcare. If, for example, if the patient is getting heart attack in the morning, you cannot treat him in the afternoon, right? So in those scenarios, the time and location dependency is very critical. Got it? Immediate action is required with respect to the healthcare. That is, even a fraction of seconds, fraction of minutes is much more important in those. Whereas, coming to the next point, privacy and security. The security and privacy plays a major role, as stating that as the data becomes huge, vulnerability becomes huge, such that the security becomes a major constraint. So that wherever the data comes, we need to provide security and privacy, right? Just a minute. Yes. Data bias, the last one. As in the majority of data mining problems, the IoT datasets can lead to biased processing, and hence a thorough understanding and scrutiny of both training and test datasets is required. That is, what data we have collected, and based on that, what action we are going to take accordingly, right? So that data bias, that means we need to have a clear understanding of both the training and data sets, right? I repeat, just the challenges, that is, one is heterogeneity of data, then varying of data quality, then the real-time nature of IoT data sets. The fourth one is the time and location dependencies with respect to the data what we are collecting through IoT devices. Then the fifth one is privacy and security. The last one is data bias. The implementation challenges. These are general challenges, security and challenges. Whereas while implementing, what else the challenges we will come across? The first and foremost thing is security. It is providing the security with the huge data seems to be much more tedious. And if those who are interested to work with the research, then accordingly they can concentrate more on security part, right? The second one is interoperability and standards. As the best example we are representing, that even I am getting purchasing any of the webcam from online, either with a low cost or with the higher standards and higher levels also. You just getting it and plug and play that to any of the either laptop or the desktop with any of the Windows versions or even Linux versions. Accordingly, it starts working on it, provided with the corresponding device drivers are installed with respect to Linux or other operating systems, whereas Windows by default it accepts, right? This is what's said to be as interoperability and standards. Whereas with respect to IoT, how we are enforcing is there what else the way in which very basically this interoperability can be achieved. The third one is technology infrastructure, right? Is a crucial for emerging IoT applications such as smart buildings, smart homes, smart cities, smart grids. Wherever the word smart comes, there the problem comes into that technology, there comes into the fact that IoT, all right? The massiveness of connected devices moves us from IPv4 to IPv6, such that the 32-bit addressing could not be sufficient, and we moved to 128-bit addressing. That too, 128 already not we have not introduced this in 2020s. Even though we initiated, it was started in 2010 or earlier on cases also. Now it's time to utilize all the vacant spaces or the vacant slots of IPv6 too, right? Then workforce. It's challenging to change the mentality of the current force, because wherever that new technology is there, as a human being, always it is very hard for us to move to the new technology, even it provides more convenience for us. So with respect to the business point of view, they will always interested to hire the experts with much more knowledge. Whereas to cope with the current technologies, no other way. We need to gain knowledge on the latest technologies. Then the high investment cost. That means the sensors with the low power is low costlier, whereas the sensors with the higher processing with the higher backups, then we need to spend a lot. Likewise, we need to compromise with the pricing based on the requirements. Plus the energy. This is what those who have done their research work, or they have done working with WSN wireless sensor networks. They will be knowing more about the energy consumption, right? There are nearly hundreds, thousands of papers, research papers in the energy with respect to WSN alone. In those, low power with less noise, low power with high noise. Even though I am getting higher noises, how to work with, how to maintain the energy of a particular node with longer lives. That the same scenario V2 will be affected with IoT. Then handling or managing the energy with respect to time is very tedious. It has to be concentrated. Right. At last, to summarize, what else the major processing we need to compromise, or we need to go with challenges, or implementation challenges and solutions is privacy, data protection, power consumption due to the limited battery sources, and global misinformation systems, global cooperations because of standards, intelligent data analytics, big data problems, and quality of service. If I want to proceed with the quality of services, I need to, without compromising the above stated criteria or the points, it has to be done. For further readings, I'll recommend you, see, if you are seeing this now, most of the contents what else we have discussed here, they have represented with other examples. You can see this. Apart from that, what else the slides I have prepared, mostly as stated earlier, the last I have represented with corresponding references. See here. Apart from that, if you are interested to explore more with other examples, then you can go for this. Thank you. Any queries or anything else has to be discussed, ma'am?
Thank you, sir. It was really a valuable session for all of us. Participants, now you can post your queries in chat box.
Either I could able to see chat. Either you can discuss with me or directly can 10 a.m. to session feedback will be sent. Sorry, I have not seen the chat at all. Now only I am seeing the chat. I couldn't. I was since I was directly presenting. I couldn't see the chat. Now only I am seeing. If you have any queries, you can post it in the chat, or else you can directly discuss with me, so that we will proceed further.
Okay, Bhuvili ma'am, you can propose your response.
Yeah, okay, ma'am. Sir, the most valuable talk on IoT will be very useful for every participant. It was really an impressive session along with essential attitude behavior required for the beginners of IoT. We are sure all the participants would have attained a good knowledge on IoT, its protocols, levels, architectures, etc. Once again, we thank you for your valuable inputs given, which will certainly improve our ideas on IoT, sir. We are eagerly looking forward for much more interactions in the years to come. Thank you, sir.
Thank you, ma'am. Thank you, the Lada Jyoti madam, HOD madam, and the management, the principal, for giving me this opportunity. And even in this is the right time for me to thank our management of directors, the principal of our college, to provided with such sort of facilities. Thank you, participants. Thank you for your
Thank you, sir.
presence. Thank you, ma'am.
Thank you, sir. Participants, kindly join the afternoon session by 1:30 with the same link. Thank you.
I'm stopping sharing the system screen, ma'am.
Okay, sir.
Thank you.
Okay, sir. We will wind up the session. Thank you all.